Today's lesson, we're going to be talking about functions, alright? And more specifically, what makes a function a function. Last lesson, we learned about what a set of word pairs were, and that is a relation. We talked about inputs and outputs. Inputs are our x values, outputs are our y values. We talked about domain is the list of inputs, range would be the list of outputs, and we learned about the special brackets that we use to list them. Alright, if you missed any of that or need any refreshers, go check that on my page. But today, we're going to be talking about the next step, specifically what makes a function a function. So, to begin, what makes a function a function? Every input has exactly one output. Alright, every input has exactly one output. Alright, so that is what makes a function specifically a function. Every input, and we know that inputs are our x values. Alright, so inputs are our x values, and our outputs are our y values. Alright, and we call a set of outputs a range. Alright, so every input, every x value, has one and only one corresponding y value or output. Alright? And one way that we can show and visualize if it's a function or not is by using arrow diagrams. Alright? So arrow diagrams show what inputs lead to specifically what outputs. So shows what inputs lead to what outputs. And you'll see in the example, when we deal with example 1, what I mean by that. Alright? So, a function, what's a function? Every input has only one corresponding output. And we can use arrow diagrams to show what inputs lead to what outputs. Alright? And using arrow diagrams, it kind of helps visualize if it's a function or not. It's very easy to see. Alright? So we're going to begin with this example. It's a chart that shows x values and y values. And we can call this whole thing a relation. Remember, a relation is just a set of word pairs. An ordered pair is an x and y value. Alright, so what we're going to do, we're going to just list out horizontally, we're going to list out vertically our x values or our domain. And I always say when we're listing out in arrow diagrams, always go from smallest to greatest, or least to greatest. Alright, so we're going to start with our smallest x value, which is -6. And then goes -4, 0, 7, and then 15. Ooh, boy. Alright, so we just got that from our top part of the graph, which shows our x values. And then we're going to show our y values, or list out our y values, or our range. Alright, so we're going to start with, again, our smallest, and we're going to go into our greatest. Alright, so our smallest y value over there is -8. Then we got -3, 2, 4, and 6. Ooh. 4 and 6. There we go. So all it is, I just listed out the y values that I know are in the bottom of the chart from smallest to largest. Alright? So now all we got to do is show what our inputs, our x value, what corresponding y value goes to it. Alright? So we got our input value of -6. Our corresponding y value would be -3. So you're going to do an arrow starting at -6, and you're going to make it go and point to -3. Alright? Not the best. You want to try to make sure it's pointing directly toward the number it's looking for. Alright, so -6 is pointing to -3. We got -4, and that's going to be pointing to, or corresponding to, our y value of 2. So this input is leading to that output. Basically it's saying when you input -6 for our x value, the corresponding y value that you get out would be -3. Alright? So that's what the arrow means. You input -6, you get out -3. Alright, when we input 0, we get output of -8. Let me get that from the chart. So 0 goes toward -8. Alright? So then we got 7, our input of 7 is corresponding to our output of 4. So that arrow goes straight across. And then finally, our input of 15 gets our output of 6. So we start at 15, we start our input, and we point toward our corresponding output. Alright? And the way we know if it's a function or not, is are there more than one arrow coming off a single x value? See, we have -6 only has one arrow coming off of it. -4 only has one arrow coming off of that input. 0 only has one arrow coming off of it. 7, that input only has one arrow coming off, and the same for 15. So because every input has only one arrow coming off of it, we know it's a function. Alright? So every input has exactly one output, which means it is a function. Every input has exactly one output. And because our definition of function, every input has exactly one output, because that is true in our example 1, this system can be related or can be named a function. So it is a function. Alright? So because there's only one arrow coming off of the inputs, every individual input, it is considered a function. Alrighty, so we got 2 examples up on the board. If you want to, you can pause the video and write down the examples if you want to. Or you can, whatever you want, whatever makes it easy for you. Alright? So, clearly these examples look a little different than the last one. Because these ones are in ordered pairs, alright? The last one was in a chart. This one is already in ordered pairs. Alright? So we're going to do the same thing. We're still going to make an arrow chart, and we're still going to figure out if it's a function or not. Alright? So, first thing I would say, let's get a list of our x values, our inputs, or our domain. Let's get our domain. Alright? And in the case of an arrow diagram, we don't need to worry about the curly brackets. Alright? For this case, all we gotta do is list our domain going vertically. Alright? And I always say list your domain and your range chronologically. Alright? So we have our x value. Remember, our x value is our first number in our ordered pair. Alright? So our smallest x value will be -4. -4. Our next smallest x value would be 2. And just like when we were listing out our domain and range horizontally, again, we see 2 here and we see another domain of 2. We only have to list that domain once in our set. Alright? We do not need to list multiple of the same domain multiple times. Just list it once. Alright? So then we have 5 as our other domain. Alright, next up. Now we gotta list our range values, or our y values. So our y values are our second number in the ordered pair. Our smallest y value will be 1. We got 1, and then we have 3. 3 would be our next smallest. And then we got 6. And finally, we have 7. And if you're watching this 10 years from now, I bet all the kids are going to remember 6, 7. Alright? It's 2026. A lot of kids are saying that. Yeah, we don't know why, but they are. Alright, so now we just got to draw our arrows. We got to do the arrow from our input to the corresponding output. Alright, so in this ordered pair, our input is -4, our corresponding output would be -1. So we need a line, an arrow going from -4 pointing to 1. And that's just saying if we input -4, we're going to get our output of 1. Alright? And we just get that from our ordered pair. Next up, we got 2, 6. So our input is 2, and we get out +6. So we get 2, 6. There we go. Next ordered pair, we got 5, 7. So we input 5, and we get 7 out as our output. And then finally, we have 2, 3. We input 2, and we get out 3. Now remember, our definition of function, every input has exactly one output. Alright? So, if we look at these numbers, how many inputs, or how many outputs does this -4 have? It has one arrow, so this input of -4 has one output. We're looking at now 2. Well, I see 2 arrows coming off of 2. That means that this input has more than one output. It has, if you input 2, you can get an output of 3. And if you input 2, you can also get an output of 6. So right there, that should tell us that this input has more than one output. This is not a function. Alright, so this is why we show arrow diagrams. If you see, hey, this 2 has 2 arrows coming off, automatically not a function. Alright? But then we have 5 has one output of 7. But because this 2 has more than one arrow coming off of it, or more than one output, it is not a function. Alright? So we're going to say an input has more than one output. And because of that, this is not a function. So not a function. Not a function. Very good. Alright, moving on to example 3. Again, we have ordered pairs. Let's put it into a list of our domains and our range. Alright, and we can do it vertically. So we do not need, again, we do not need our fancy brackets. Alright, just list them vertically. Alright, we're going to start with our smallest input, which would be in our case, -4. So -4 is the smallest, then we go up to 1, and then 2, and then our largest input would be 3. Again, all I'm doing is just listing those inputs, or our x values, chronologically, smallest to largest. Chronologically, numerically, same thing. No, I'm just kidding, not the same thing. But smallest to largest. There we go. Alright, so now we're going to do our y values, or our outputs. Alright, smallest output we have up here, I see is 1. Alright, do we have to list 1 twice because it's up here twice? Nope, only list each individual number, only once. So if it shows up twice again, only write it once in your list. Alright, after that we got 6, and then we got 14. So clearly we see we have more inputs than outputs. Alright, so I should say more of a variety of inputs and outputs. Alright. So now, let's just do our arrow diagram. When we input -4, we get out +1. So that line should go like that. We input -4, get out +1. Next up, we input 1. What do we get out? We get +1 out. We get +1 out. We input 2, we get 14 out. We input 2, our output value would be 14. We get that from the ordered pair. And last, we input 3, and we get out 6. Alright, well, you might be saying, hey, Mr. Cover, why does the output of 1 have more than one input? That can't be. Look back at our definition. Every input has only one output. There's a specific order, input to output. One input to one output. Alright? So, just like before, let's look at each input. How many inputs does -4 have? -4, you input -4, you only get 1 out. So that's good. That's 1 error off of -4. We're good. When we input +1, what's the output we get? We only get +1 out. Alright? So there's only 1 arrow coming off of that x value. Next up, we got 2. The only input, or the only output we get when we input +2 is +14. There's only 1 arrow coming off of +2. So we're good. And last thing, when we input 3, we only get 1 arrow off of it, which is +6. We only get 1 output. So each input only has 1 arrow coming off of it. Over here, this input had 2 separate outputs. So that made this not a function. But because every input has 1 output, we're good. That's still a function. We can have repeating y values, we can have repeating ranges, we just can't have repeating x values. And I'm going to write that down. So, every input has exactly 1 output, which means it is a function. It is a function. So, over here we're going to have 2 key points that will help us with remembering how to determine if a function is a function. Alright? So, we have our domain values, our x values. If there are repeating domain values or x values, it is not a function. Alright? If there are repeating domain values, and we know that our domains are our x values. Alright? Our domains are our x values. It is not a function. Alright? Not a function. So if there are repeating x values or domain values in our relation, it is not a function. Okay, let me get a different color. So if there are repeating range values or y values only, it is still considered a function. So if there are repeating y values or ranges, only, so if there are repeating range values, the y values, only, if there's only repeating y values, it is still considered a function. Still considered a function. So still a function. Alright? So, if there are repeating x values or domains, not a function. If there's only repeating range values or y values, it is still considered a function. If there were repeating domains and repeating y values and range values, it is not a function. Alright? So as long as there's not any domain values that are repeating, it's a function. It doesn't matter how many range values that are being repeated. And you'll see that in these next 2 examples. Alright? So here are the next 2 examples. So we have example 1 up here, and we're going to draw our arrow diagrams, alright? So our x values are located in the first part of our ordered pair. And remember, we want to go from smallest to largest. So we're going to go -2. Back up. I don't know why I put that. Not -2. Looking at the wrong number. Alright, remember x values, first numbers, right? So our smallest x value will be -3. So -3 is our smallest x value. Then it goes +3. +3 would be our next. Then we got 4. And then we have 7. So those are our 4 domain values, because those are our x values. All right? Then we have our smallest range value would be -2. And we listed only once when we are listing our range out. And then our other output value, our range value, would be +10. All right? Input values, x. Output values are y. All right, now we do our arrow. So we draw our arrow from our input to our output. So we start at -3, and we get out -2. So that line goes like that. All right, number 7. When we input 7, we get 10 out. When we input 4 in our x value, we get -2 out. And then when we input -3, we again get -2 as our output. Alright? So if we look up in these order pairs, before we even do this, we can tell already if it's a function or not. We can see that all our domain values or all our input values are different. So before we even need to do our arrow chart, we already know, hey, we don't have any repeating x values, it's a function. Alright? Showing the arrow chart will just kind of visualize that as well. Yes, we have repeating y values, but looking back here, if we only have repeating y values, we are okay. It's still a function. So in this case, it's a function. This is a function. No repeating x values. A function. Good. Now we've got one more example. All right. So I'm going to do the arrow chart, but you may already see if this is a function or not a function, just based on that rule alone. All right. So we got our x values and our y values. All right. So what's our x value here? It's 3. 3, 3, 3. So we have the same array or the same domain. Excuse me. The same input. Excuse me. Same input for every single relation or every single pair. Excuse me. All right. What are our outputs? We have -12 as our smallest. And then we have 2. Then we have 4. And then we have 8. Alright? So we have those 4 different outputs. Alright? We got those from our y values. Now, let's draw our arrows. When we input 3, we get out 4. So it goes like that. When we input 3, we get out 8. When we input 3, in this case, we get output of 12. And then we input 3 from this ordered pair, we get 2 out. So, as we can see, this input of 3 has 4 different outputs. And if we have repeating domains or multiple arrows coming off the same number or same input number, it is not a function. Alright, so that is not a function. Not a function. Alright? So, to wrap up this whole lesson. Alright? We got inputs and outputs. A function, what makes a function, every input, our x value, has one and only one corresponding y value. Alright? We did an arrow chart, and this arrow chart just shows visually what inputs relate to what outputs. Alright? So, if there are repeating domain values or x values, it is not a function. And we see that right here in example 5. We have 3 or 4 different outcomes for this input. We have 4 different outcomes, -12, 2, 4, and 8, all for the same input. And because of that, it is not a function. We can have repeating y values, like up here, but we don't have any repeating x values. Alright? So next lesson will be about evaluating functions. Just putting in certain inputs to a function and seeing what outputs you get. So, if you have any questions about this, let me know. Post in the comments. I did have a student today during class give me a really good slogan. Don't be the negative in the world, be the positive. I like that. So, thank you to that student. You know who you are. And I'll catch you guys next time.